Now let's look at this question. Okay, I'm going to sketch this graph uh, in this domain and describe the transformation. Okay, so first let's describe the transformation first. Okay, so because there's a minus, so we have a reflection on x-axis. Okay, after the reflection we will do dilation. Okay, dilation by a scale factor of 2 along y-axis. Okay, and there's a coefficient in front of x in the bracket, so there must be another dilation along x-axis. Okay, so dilation by a scale factor of 1 on pi on 6, okay, which is 6 on pi along x-axis. Okay, x-axis. Okay, and well, it's basically the same principle there. The dilation is 1 divided by the coefficient of the x inside the bracket there. It's 1 on b, and then here your b is pi on 6, so 1 on pi on 6 is the reverse of it, is 6 on pi. Okay, now let's do translation. There's no horizontal translation, but a vertical translation, so it's 12 units up. Okay, now let's draw the graph. Okay, the standard graph is in this form. This is a standard sine wave, x, y. Okay, so because we have a reflection, so our graph should look like that. Okay, and there's a dilation, so that means along there's dilation along y-axis, and the scale factor is 2, so amplitude is 2. Okay, dilation along x-axis has a scale factor of 6 on pi, so our period is 2 pi, okay, times that, or 2 pi divided by b, okay, which is 2 pi times 6 pi, and the pi cancels out. The period is 12, which fit with our domain, so we only have to draw one period of the graph. Okay, now it's 12 unit. It moved 12 unit up, so the neutral point is y equals to 12 instead of y equals to 0, 0. Yep, and the maximum of the trigonometry graph is always your neutral line plus the amplitude, which is 12 plus 2, okay, 14, and the minimum point is your neutral line minus the amplitude, which is 12 minus 2, which is 10. Okay, now after we gathered all the property of the graph, we can draw our graph. Okay, we have x and we have y. The neutral line is y equals to 12, so let's draw it here. Draw it in dotted line. Okay, y equals to 12. Here is 12. Okay, the maximum number is 14 and the minimum is 10. Okay, so the graph has a period of 12. Okay, let's say the graph has a period of 12 and it follows this shape, so I will have a point there a maximum point there, and a neutral point there, a minimum point there, and a finishing point there. It's the same as the line, the sun shape, and we connect it. Okay. Now we can label everything there. This point is half of the period, which is 6. Okay. This point is 3. Okay. The midpoint between 0 and 6, and here is the midpoint between 6 and 12, which is 9. Okay, and yep, that's it. That's our graph. Y equals to minus. Oh yeah, sorry, I made a mistake because we should have a minus shape, so it's my mistake. Okay, so we have a reflection there. It's minus, so it starts from here. Okay, and the shape should look like that. Okay, when we have minus, so there, there, so the graph should look like something like that. Okay, so our graph is y equals to minus 2 sine pi on 6 x bracket plus 12. Okay. Okay, this is how do we draw this graph. Okay. Now I'm going to show you. Also, sorry. By the way, if there's a horizontal translation, find the value and just move the graph left to the right, left and right. Okay. Okay. Yep. Yep. Okay. Now I'm going to draw a tangent graph. It's a tan graph. So, for instance, if y equals tan, say 2 tan, and okay, so y equals to, say, minus tangent 2x plus 1. Okay. Okay, the domain of the graph is say from circle bracket from 0 to pi. Okay. Firstly, we have to look at our standard graph of tan. Our standard graph is something like that. Okay, x and y, and it goes there, and we have asymptote at positive pi on 2 and minus pi on 2. Okay. Now, let me. Okay, we have a minus sign there. So the shape of the graph would be reflected on x-axis, which looks like this. Okay. Also, the period of the graph is, well, pi divided by 2. Okay, pi divided by the number there, because in the standard graph the period of tangent is pi, whereas in sine and cos graph, standard graph, the period is 2 pi. The period of standard graph is 2 pi. That's why when we try to find the new period of the graph, we use 2 pi divided by b, and in this case we use